Welcome to Across the Globe. Today we will learn about networking in Go. The Go programming language includes an extensive standard library for networking tasks. This library equips developers with tools to effortlessly build resilient networking applications. For instance, developers can leverage the library to implement features like creating web servers, handling HTTP requests, or establishing network connections to communicate with remote servers or devices. By harnessing these capabilities, Go empowers developers to craft efficient and reliable networking solutions without investing significant time in low-level networking implementations. TCP communication in Go can be achieved using the net package. This enables developers to create TCP servers and clients. In the given example, a TCP server is created using the net.listen method to listen on a specific port. Once a connection is accepted using ln.accept method, communication can occur via the connection object. In this scenario, hello world is written to the connection using fmt.fprintf method. The Go programming language offers a built-in HTTP server for managing HTTP requests. To create an HTTP server in Go, you first need to define a handler function that specifies how the server responds to HTTP requests. In the provided example, a simple server is created with a handler function that writes hello world as the response. The http.handlefunc function is used to register the handler function with the server for a given route, / in this case. Subsequently, http.listenandserve starts the server on port 8080. This setup enables the server to listen for incoming HTTP requests and respond accordingly based on the defined handler function. In a real-world scenario, this capability can be leveraged to build web applications, REST APIs, or microservices using Go. For instance, an e-commerce platform can utilize a Go-based HTTP server to handle product catalog requests or user authentication. This functionality provides a foundational tool for managing web traffic and serving content in Go applications. Go's concurrency model allows for efficient handling of multiple network connections concurrently. By leveraging goroutines, Go enables developers to create highly scalable network servers with ease. The example provided showcases a simple TCP server implemented in Go. The main function sets up a listener to accept incoming connections. Upon accepting a new connection, a goroutine is spawned to handle the connection concurrently, while the main loop continues accepting new connections. This ensures that the server can handle multiple clients simultaneously without blocking the main execution. In this example, the handle connection function is launched as a goroutine to manage each incoming connection. It simply sends a hello world message to the connected client and then closes the connection. By utilizing Go's concurrency features, such as goroutines and channels, developers can create responsive and high-performance network applications that can handle a high volume of concurrent connections efficiently. Networking in Go is like sending messages through a postal service. Just like how you write a message, address it, and send it out, networking in Go involves creating a message, specifying a destination, IP address, and sending it out through a network connection. The recipient of the message processes it and may send a response back, similar to how you would receive a reply to your letter. In a program, you would use Go's built-in networking libraries to establish connections, send and receive data, and handle any responses received. Hey, Code Conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The provided Go code snippet demonstrates how to utilize Go's built-in net package to establish a TCP connection, send a message, and receive a response over the network. Here is a breakdown of the code. 1. The net package is imported to enable networking functionality in the Go program. 2. The main function starts the execution flow of the program. 3. A TCP connection is established with a server running on localhost at port 8080 using net.dial. 4. An error check is performed and the program exits with an error message if the connection fails. 5. A message, hello server, is sent to the server using the con.write method. 6. The response from the server is read into a byte slice response with a maximum length of 1024 using con.read. 7. An error check is performed on the response read operation, and the program exits with an error message if reading the response fails. 8. The received response is then printed to the console as a string after slicing based on the actual size of the response. Real-world applications of such networking code in Go may include developing client-server applications, data exchange between client and server systems, or creating networked services. For example, a chat application could utilize this code for sending and receiving messages between clients and a centralized server. An industrial application of networking in Go can be found in distributed systems, where multiple servers communicate with each other to share resources and distribute workload efficiently. By utilizing Go's networking capabilities, these servers can establish connections, exchange data, and coordinate tasks seamlessly, ensuring smooth operations across the distributed system. Another real-world example where networking in Go plays a crucial role is in cloud computing platforms. Platforms like Kubernetes leverage Go's networking features to manage networking configurations, establish communication channels between containers and pods, and enable seamless interaction between various components within the cloud infrastructure. The robust networking functionalities provided by Go contribute to the scalability, reliability, and performance of cloud-based applications. Across the globe, organizations and industries rely on networking in Go to power their distributed systems, cloud computing platforms, and various networking-oriented applications, enabling efficient communication, data exchange, and resource management in a reliable and scalable manner. Keep learning, stay curious, and I'll catch you in the next video.